Okay, Algebra 2 students, here's a video for example 4 for section 3.5. We're going to interpret the zeros of a function. They have a little story for us.
Acme Innovations makes and sells lamps. Their profit, P, in hundreds of dollars earned, is a function of the number of lamps sold, X in thousands. From historical data, they know that their company's profit is modeled by the function shown. What do the zeros of the function tell you about the number of lamps that Acme Innovations should produce?
Well, if this is the graph, I can see there's a 0 at -2, which would represent -2,000 lamps sold. That's not applicable because you can't have -2,000 lamps sold. This one appears to be at 3, so that would represent 3,000 lamps sold. And this one may be 10, so that's 10,000 lamps sold. So it looks like they should sell between 3,000 and 10,000 lamps to maximize their profit. Or if I'm truly going to use the graphing calculator, I can picture that as, what's that, 7? So 7,000 would be ideal. Let's see how they break it down for us. All right, even though we have the function and graphed it, they're pretending we didn't. So they have the zeros, and they decide these are the factors, and then they multiplied them out to see if it's truly the equation that they came up with. Not sure why they would go about all that when you can just use a graphing calculator. So I would encourage you just to use a graphing calculator and interpret that you should sell between 3 and 10, so that's 3,000 and 10,000, or less than -2, but -2, you can't have -2,000 lamps. So I'm not sure why they wanted to compute it this way. That's old school. We have a graph, we have the graphing calculator, we're good to go. Here's a problem for it. They changed the function, same story, but they changed the profit function to be this. They want us to identify how many lamps they should sell there. So I've taken the liberty to put it into my graphing calculator already, but I didn't change the window. So when I graph it, it's coming. Oh yeah, because it's a negative x cubed this time, so it goes down, up, and then it comes back down somewhere. Let me change the window. Let me start it. Sometimes I like to have a negative value, so I don't mind going to -5, but let me go up to 20 this time. Let me take a risk, 15. I'd like it to show up on the graph, but I'm not sure how low or high I should go. Sometimes you go too high and it doesn't show up well. All right, I'm going to give this a shot. Comes down, goes up. I still don't see the high point. Comes back down. So I can tell it's in between these two values. Why not? Let me change the window one more time and make this 100 just to make sure it shows up. Well, I don't know if it's going to show up. We'll give it a shot. Still didn't show up, so they're making quite a bit of money, but I can tell it's somewhere in between here. But to be specifically, try these two. I'm going to use calculate, and I'm going to find the 0, so calculate 2, and I want to find the 0. Where is the cursor? Cursor's at 5 and 4. Let me bring it down here into to find this first 0. Right bound, left, oh, I didn't click enter. Left bound, enter. Right bound, enter. Guess. Looks like one of the zeros is at 1. Now let me find this other 0. Same process. Calculate a 0 between left bound. Sure, I can have it be here. Now the right bound, I got to get it past that 0. How far out is that 0? Here we go. Now I'm past it. Enter, enter, and I have 11 is the other one. So they need to sell between 1,000 and 11,000. What are they doing? Lamps? Lamps. Let's see what they wrote for an answer. Yep, 1 in 11,000. All right, let's see what you can do for an assignment. 18, 26, 25, 27, and 30. That's it for this video. Have a great day.